All right, so today we're going to start talking about naming ionic compounds. That's where most of this unit is going to focus, mostly in the naming aspects. So before we can begin, first we need to talk about the two types of compounds. The one we're focusing on today is ionic compounds. I'll go into more of what that means in a couple seconds. And the other one that we will discuss later on this week would be molecular compounds. Now, molecular compounds are a different type of compound, but until we go over them, there's no need to really worry about them quite yet. So first things first, and the most important thing about ionic compounds is that they form between a metal and a non-metal. One thing to keep in mind, and I'm going to roughly draw a periodic table here on the side for you guys, that everything separated out by the step, everything to the left, we consider a metal, and everything to the right, we consider a non-metal. With that in mind, what that really means is that we're looking for a cation and an anion. In most cases, we're going to talk about it being a metal, non-metal, but there is one special situation where you'll run into ammonium, NH4, with a +1 charge. That polyatomic ion does count as the cation. We consider it a metal in the sense of ionic compounds. But that's really the only situation where it won't be just a metal from the front of the periodic table. So what you're looking for is a metal and a non-metal, or a positive and a negative, coming together to form a compound. The big thing that we are going to talk about later on in the unit is that electrons are transferred in this case. So that means electrons are moving from one object to the other, rather than different situations that, again, we'll talk about later on in the unit as we kind of go through it. All right, so how do we go about naming them? The first thing you got to keep in mind when we're naming these compounds is that the cation, whatever the metal, whatever the first thing in the compound is going to keep its name. So, for example, if the metal's potassium, potassium keeps its full name. The next thing you want to remember is that the anion, whatever is negatively charged, if it's an element, it's going to end in "ide." So, for example, the element oxygen, right, becomes oxide. Now, I'm never going to be too specific on, if you put the "ide" in the wrong spot. As long as I can tell what element you're talking about, that is what I'm mostly looking for. So if you call phosphorus, phosphide, or phosphoride, either or works. I know what you mean. The thing you want to keep an eye out for is that polyatomics do not change their name. So, for example, something like carbonate, right? So carbonate is CO3 with a -2 charge, stays the same, right? It just stays as carbonate. So, for example, potassium carbonate talks about the potassium being the cation, the carbonate being the anion. Anytime you see an 8 or an ite, chances are it's going to be on the back of the periodic table. Anytime you see an ide, it's going to be on the front. It's going to be an element. All right, so for example, let's look at this first one. So here we have sodium oxide, right? Sodium oxide, because the first element, Na, right, the +1 charge, is named sodium. And again, sodium is our cation, so it keeps its full name. The oxide comes from the oxygen -2 charge, right? That's oxygen, which becomes oxide. We drop the ending, the gin ending, and become oxide. That is our anion. So one thing you're going to need to do as you're kind of going through this is have your periodic table out to know your charges. If I give you a compound like this, you're just going to look for what's usually your first element is the cation. Whatever follows is your anion. So in this case, the sodium is the cation. We have just one element following, so the oxygen is the anion. All right, in this next one, in example 2, your first element here is the K, right? So K tells us it is potassium, right? Now, in the other case, we saw that there was just one element following, but in this case, we have a sulfur and 4 oxygens, SO4. Now, there isn't a good way to say, like, hey, just look for this. If you see more than one element, just go to the back of the periodic table. Chances are it's a polyatomic, and you're going to have to find its name. So if you go back to the back of the periodic table, you'll find in the -2 charges, you'll see SO4. It's lowercase, so let me make that uppercase. SO4 with a -2 charge. That is known as the sulfate ion. So what that means is that the SO4 is known as sulfate, right? So our full name on this compound is going to be potassium, the metal, and sulfate, what we're going to call the nonmetal in this case. All right. And if you guys ever have questions with this, please feel free to email me, message me on Canvas. You can always replay these videos again and kind of get a little bit of background into what each thing is. Now, the other thing I'm going to ask you to be doing is going from names to formulas. So, for example, I could give you just the name aluminum fluoride, right? First thing you're going to do is figure out what are your two things that you have. In this case, we have aluminum, which we know is Al. And then on the periodic table, you're going to want to check for its charge. So if you go to aluminum on the periodic table, aluminum takes on a +3 charge. Fluoride, remember that the ending "ide" means it's an element, right? So we have to find the element fluorine. Ide becomes whatever the ending of the element is. If you look that up on the periodic table, it is F with a -1. Now, in that case, what you're going to need to do is just balance out the charges, make a neutral compound like we've been doing for the last few days. So we say, okay, aluminum is a +3, fluorine's a -1. To cancel that out, we're going to need 3 fluorines, each at a -1 to give an overall -3. When that happens, they cancel. And so our compound has to be AlF3. All right, so I think this is the easier ones to do when I give you the name and ask you to come up with the formula, because it is pretty much just looking things up on the periodic table, figuring out what you're going to need. All right, so again, we can do it an example from here, magnesium chloride. Now, the first thing you're going to do is figure out what magnesium is. So if you go to your periodic table, magnesium's initials are Mg, right? And it falls into our +2 category, right? So we know magnesium is a +2 charge. The next one is the chloride. Now, chloride is an element. Notice the IDE ending. That tells us that we're looking for some element with the name chlor in it. So most people might be able to figure this out, that is chlorine, right? Cl. That would help if I put the pencil back on, right? So we have Cl at a -1 and Mg at a +2. So we need to figure out a way to cancel these two charges out. The only way to do that is we're going to have to figure out how to get a -2 overall charge in there to cancel out that +2. The way we would do that is if we add another chlorine, right? That now gives us an overall -2 to balance out our positive +2, and tells us that our formula will be MgCl2 to make that a neutral compound. All right. Another example would be rubidium phosphate. So again, you'd have to go onto the periodic table. You would find out that rubidium is a Rb+1. Phosphate, notice that ending, the 8 ending here, right? That tells us it's on the back of the periodic table. That tells us it's a polyatomic. So if you go to the back of the periodic table, you'll find that phosphate is PO4 with a -3 charge. Now, you guys might see it written as PO4 3-. That means the same thing. So those are equal terms right there. It's the idea that there's 3 negative charges. Most people just like seeing the -3 charge better, so it doesn't really matter in either way. So here we have 1 rubidium at a +1 and a phosphate group at a -3. So we need to cancel out those charges. Right now we have too many negatives. So that means we're going to add in 2 more rubidiums, each at a +1. Now we have an overall +3 to cancel out our -3. And so our final formula is going to be Rb3, because it took 3 of them, PO4. Now again, you can write it without the parentheses. I just like putting the parentheses on there. It tells you that that PO4 is all together. That way it's not too confusing when you're looking back at these. All right, so some special situations. Now, if they don't come into those first 2 categories in the periodic table, so here's my rough drawing of the periodic table, right? We know this is the +1, this is the +2. We don't know any of the charges on the middle ones. And so the way we kind of talk about that, the way that we can give that information to people, is that we use Roman numerals. So it's really important that you remember what your Roman numerals are. Just for a refresher, 1 we write as an I, 2 is, well, let's do this better. 2 we write as II, 3 is III, and 4 we write as an IV. So anytime you see a Roman numeral, what that's telling you is the charge. And this is probably one of the most important things out of this unit you're going to need to keep in mind. It never tells you how many. All the Roman numeral is telling you is what the charge on that metal is. All right? So don't get confused. Don't think that a Roman numeral tells you you have this many of an element. It's only telling you the charge that you have in that case. All right, so for example, the name of the compound for CuCl2, right? Now I tell you guys here it's copper 2 chloride, but how do I know that? How do I know that it was copper 2 in that case? So what you're going to have to do in some cases is figure out what the charge was with only a little bit of information. In this case, we know that our two components are a copper with some unknown charge, and we know that we had 2 chlorines. Now, if you go to the periodic table, right, the anion always has a known charge. So if you go and find chlorine on the periodic table, it is a -1 charge. So it took 2 -1 charges to cancel out that copper. So right now, what's the only number that can cancel out a -2? It must have been a +2, right? So in this case, we must have been using copper with a +2 charge. So to write its name, we just write copper 2. Roman numerals go after the cation, the metal in this case. And we now need to just name our anion, right? The chlorine, which becomes chloride. All right. So again, the 2 does not tell us that we have 2 coppers. We only have 1 copper in this case, right? There's just 1 here. The 2 tells us that copper in this case was a +2 charge, and it took 2 Cl minuses to cancel that out. All right, last but not least, I could give you a name, right? Iron 3 nitrite. Again, this 3 does not tell you that you have 3 irons. It tells you that your iron, your Fe, is a +3 charge. Next thing you're going to want to do is figure out what is nitrite. Again, look at that ending, the ite. That tells you it's a polyatomic. Go to the back of your periodic table. If you look up there, it is NO2 with a -1 charge. So again, we're going to have to balance these out. That's going to take 3 NO2s, each at a -1, to balance out the 1 iron at +3, right? So we would write the formula as FeNO2, and it took 3 of them, so the 3 comes outside of the parentheses. That says that it took 3 NO2s, 3 nitrites to balance this out, and that is our balanced formula. So again, if you have any questions with these, please feel free to reach out to me through the Remind app, through Canvas, through my email. Again, the email you want to use is kmacker@ridleysd.org. All right, I'll try my best to be answering these with you guys as quickly as I can.